Oh, wait a second. Good evening, everyone. For some reason, camera every time decides to stop working right before I start stream. So, let me open my stuff back. What's happened with this? Debugger. Known. Okay. Seems fine. Should be fine. This must be stopped. This is connected. All system online. And we're good to go, I hope. What the... Okay, so last time I was trying to understand how the main game structure is built. So, where is it? Where is my bookmarks? Bookmarks, okay. Main loop. Function. Work. Vtable. Game struct. So here we got the main struct, but I also found, ouch. Can I move you in here? Yeah. So, host address table. Game. This address contains where the game struct is. Let me check. Can I open the data structure itself from here? Okay. Game struct. We got a lot of stuff here. Window name, vtables, foreground window. Hospital. Player hospital. Hospital object. Find use of. Code unit. I need a dot. Just dot. Player hospital. Okay. No, hospital file address. That's what I want. And so let me note it. This host file address and game struct address. Bookmark, please category hospital. Well, let's go back. Game struct. This one. Okay. Now, where's my game? Debugger. Let me connect you here, and I want to watch these two addresses. So this already populated with something. And this address also populated. So right after the start. It's dropping the addresses. Okay, 0 and 0. We got entry point 0, 0. Let me check main loop. Let me see the main function, I think. Yep, I found it. So main func, I want to, first of all, where are you coming from? Here. You called by register or what? Oh no, it's called by address. Because when it's called by register, it looks like that. All like that. And it's FF. Okay, so should I place call breakpoint here or on main function inside? If game structure address not 0, and table is window high not 0. Table field. Okay, then let's move this breakpoint here. We will start. Everything is 0. Ink. And we are in our main function. In args, we can see. So they 4, 8, and something on the stack. So if I will open this in dump, argc, strange. This. Or it's not the correct one yet. Yep, it's a wrong one. They didn't fix the stack yet. So we need to let me move it like that. So return address is here and args is here. Oh, argc contains amount of, let's count. What is the signature? C++ main func. As far as I remember, first it's the amount and second is the actual array. So argc must be counter number of arguments passed to the program. So basically the size of this array. Pointer to the first element of the array argc +1 pointers, of which the last one is null and the previous one, if any, point on null terminated multi-byte string. Yep, so first argument, it's executable itself. Okay. Yep, that's correct. So And this will go here. This is 0. Then we go call this, and we will return something from here. If heap handler is null, okay, create heap with 0 values. What? MSDN. You create function. Options. Enable execute. Nope. Parameter can be 0. So 0 is just no options. Initial size. If parameter is 0, the function commits one page. To determine the size of a page on the host computer, use getSystem info. Maximum size of a heap. So it creates if it's 0, heap can grow in size. Okay. So it creates 0 heap, but it can grow. And what we return here, we are checking if handler is null and mask with a F. Minus heap plus 1. Okay, let's jump in. We are grabbing address, testing it, then we are pushing zeros, calling this, getting. Oh shit, I accidentally entered this function. I don't want it. Enter. Now we got this in EAX, which is handler. Then we are moving from the same address, so we are we are moving result into this, just because it was cutting out, I wasn't able to understand. So we saved again result here. We are comparing it to 1. They got some side effect with a compare. Assembly. Because there is no jump after. So they are comparing not for the sake of checking flags, but for having something in EAX. CheatEngine. They got good enough explanation. Okay, so compares and set the flags. So they only set the flags. Both operands are not changed. Compare is used in conjunction with jump, but there is no or set instruction. Set condition code used by GC. The move set instruction are based on the result of a compare instruction. Appendix B. So we got SBB. Do you have this? No. Integer subtraction with borrow. At the source operand second and the carry flag. Wait. Maybe. Yep, the carry flag is set with a compare. So compare carry flag. For now it's 0, but if we advance, they right now not equal. Zero flag 0 P1 F1. So carry flag is 0. It adds in itself, so this to this with 0. So it basically doubles itself. Adds and subtracts the result from the destination operand. So we got 0 here. So depending on the carry flag, we will get either 0, either 1. The result is stored in the destination. So we are saving here 0. Bottom. Okay. And we are masking it with all ones and 0. What the point? Because if we got 0, we will get 0 because every 1 will be matched to 0. So this all ones will be annihilated by the zeros. But if we got even 1 at the end, we still get 0 from this operation, because this 0 will kill the last one, and then we're adding 1. So we need to nullify. Interesting. So from this part we will always get 0 and we will always get 1 back, basically. Great. increment and we will return 1. Let me try again. Now I will modify the code. So run, and my breakpoint failed. It's annoying. Why are you losing breakpoints? Tell me. No. Whew. Okay, let's try again. We are running entry main. So F8. Then we are getting in. Let's pretend that this one failed. No, we don't need to pretend. It's 0. We are getting heap. And voila, we got EAX. Now let's modify this and we will get 0. We will move it here, compare it to 1. So this flag will be 1. So this will be -1 right now. So there will be E, F, F, and all Fs. Okay. If we get all Fs, it's all ones. And this mask will return this FE again. Okay. So we will get 0 or FE, and FE it's can we see the normal representation of FE? So basically it's -1. And 294, yeah. But can you show me the freaking signed version of this? Okay, it's -2. and then we increment it to, so we will get -1 right now. So basically we are checking if heap was successfully created. Compared to -1, run empty return. We will call this, it's empty return. It should be apparently a debug function which was removed by the compiler optimization. And we fixing stack, moving EAX1, which is error code. Why it can't find this part, and it will pop and return here. Interesting. Three, 357. So we are here actually. It thinks that we are here, but we not. Yeah, we are comparing game struct address, which is this. With 0, and it's equal. We are jumping to here. And voila, we will close the game basically. Push module and call exit. Come on. I will call this and it will close it. Okay. Now we need to go back. Again, grab this, make a breakpoint. This. Run. Call. So, will you think? Okay. So we can rename is heap created. If it's -1, and we'll go here, but we know that basically it will create it. Now compare, okay. Jump not equal. Okay, we are jumping here. We are setting this address to this value. What it can be? No equates. Wait a minute. 8. Can it be this offset? D8, but it's C8. It's 9F A3 F. So next maybe should be A0 1 2 3. So this is 2 dot files which are set to this and read here. And when we are reading it, what we are doing with this? Push, move, and call. So we're calling this function with this. So I can rename this to basically its value. This is again written only here and equal to. So we should know that this is constantly 2. Okay. Move and move. Then we are moving 1 to ebx and calling this function. 15 with a void. We are doing a lot of for loops with some dots. Oh. Okay, let's check. 7. 0 out EAX, push, move 5E. 5E, it's starting iteration. var not equal 0, plus minus 1. As far as I know, it's like a classic optimization. Hello 765, how is your morning? What are we modding today? We are still modding Theme Hospital, so nothing new. I decided to go from the main function and look how the game starts. So I was noticing this for loops, and was starting to explaining why you can see this. Usually, like, I remember there was a times when I only started like programming. Everyone was running towards optimization. So you could find a lot of articles and videos about how to optimize your code by using code as close as you can to the assembly. That's one of the examples. So to write for loops, not from like usual e equals 0 and increment until you need it, like how many times you need it. Optimization was to make it like compiler will do, and do it other way around. You go backwards from your value, so you get I to maximum value and then you decrement and go down. It's like more optimized, it's faster. But then everyone switched to like, you need to write understandable code, don't optimize it too much. So it was called like micro optimizations, which will save you like a second, like millisecond of a computing time, but you will lose much more time when this code will be will fall under refactor or expansion. So a person who didn't write this code will think why you make for loops so complicated going other way around, and you will actually waste more time by understanding other people code if you will write it too optimized. And like everyone switched from more optimization to optimization is bad, don't make it harder to read the code. It doesn't don't worth. And as far as I know, and again looking at this code, I also don't think they wrote this for loop backwards. I think compilers are smart enough, even at this time, and now they should be smarter. They will do it for you, so you can write a normal, human readable and understandable code, and compiler will do all of this optimization for you, and you will find this for backwards in the assembly code. So that's why here there's a lot this backwards force. It's actually simpler for computer to make this, to make the loop like that. So, what they do here with all of this data, all from the different regions, basically. This is kinda near, but this E1090, and they got these regions, and they just nullifying this memory. So I think they are preparing memory to be filled with something. And we need to know. So 5e. How much is 5e actually? 94 byte. Do we have any game files which will fit there? Oh, you will not believe. But it's kilobytes. 93 kilobytes. If it's just bytes, it's too small for something. Okay, let's check. First of all, I was playing StarCraft 2 with a friend and we were playing an arcade map. While playing, he talked bad about the map and all chat in the game ended for him. So I guess the map maker programmed the map to end the game if he talked bad about it. Pity and weird. So it makes sense. If you don't like this map, why waste your time on it? Go play something else. There's a lot, I think, of good maps in StarCraft, especially on the second one. Oh, there was a freaking something. I don't know if you watch Louis Rossmann. I will not be able to play the video on stream. Where is it? No, don't play the video. No. Copy, clean link. Muted? No, not the problem. Not with the sound. It will start lagging. If I will try and play YouTube video on the stream, my laptop can't handle it. This should be fine. So there is the video. I think it's correct. Link here. Yes. So about trains. So in Poland, they discovered by reverse engineering the code of a firmware of the train. There was a code, first of all, which was tracking where train is, and the interesting part, it was tracking where it was serviced, and if for some reason you serviced not in the official, like certified service of this company which constructed this train, it will give you an error after that. So they checked location, and if it's matched to unauthorized center, the train will just break. And also, after they found more interesting code where there was a if else logic, which was just checking the date. And if the date is close enough to the service time, it will throw a specific error, like something malfunctioning in the train. That was like just awful discovery. And how they said, when they disclosed this discovery, company updated this firmware and erased all of the evidences from this code. And also they trying to sue these guys who found this, like for the reverse engineering. They say like they didn't have a right to reverse engineer our firmware and we will sue them. And that's just interesting what will happen next with them. I think they even provided some links where you can actually check it. I didn't check, so it's just what I heard. You can watch it for yourself and make your own conclusions, but I will not be surprised with this. Okay, let's go back to our problems. Again, about like stuff in the code, I think I already talked about this. When the Rockstar was caught by selling on Steam the pirated versions of GTA. So when they decided to release old GTA series games on Steam, they didn't bother to disable the protection because they was too lazy, and they just grabbed pirated version where it was already disabled and just pushed it to the Steam sales. People was looking in the code and also was finding like signatures of hacking groups who hacked the game in early years. Like Razer, I think they found. That's old. And like how I remember, they explained that the problem was that they got protection system in a game and also like traps. So if you break protection system, the traps will trigger. So game became unplayable, was throwing errors and crashing. And they pushed this version to Steam. But after it was uncovered, they also finally made the correct job, disabled everything from the source and pushed the normal versions. So companies sometimes do really fun stuff. Okay, we are was derailed. Let me check this address. Follow in dump. So we are saving in EDI. No. I'm still not there. I'm on the wrong. We still didn't make this. So ECX, it's basically counter. So I can rename it to I. and you can see immediately it looks much better. So this var so EDI, it's a destination usually, and if we will look at rep tos d, rep tos d, so we are storing double words repeatedly. Store EAX at EDI. So right now EAX is 0, and we will be storing zeros to EDI. Okay, and EDI will be just this address. Yep. So we will be nullifying this memory. Okay. So I can demonstrate this, I think. Interesting. So we got 5e. I can like do it like that. I will just randomly press 1 and 0. So we got all of this region, and after this it will be all zeros. Voila! We nullified this. So basically this is a start address. And we are just moving through this. Let me calculate some stuff. If we will get this address plus 5e, we will get 4e. Ah, wait a minute, this is lower. D, D, E. 1. No, they are not consecutive. Going back to sleep. Have a great stream. Oh, have a good sleep. Why you even woke up this time? Is this again the alarm which got you up? I woke up for bathroom. Ah, okay. Don't drink too much before the bed. You caught me. You was peeing too loud. Remember, the pee is silent, especially at the night. Following dump here. Or actually, you can check. You get 2 animated emojis now. So this and this. I added second one yesterday. I think I can add at least couple more. I will do it later. Maybe at the weekend. Okay, back at business. So here we are zeroing to a6. Six, seven, eight. Okay. Stores B. Oh, so we are storing like it stores by double words. That's the maximum you can get in 32 bits. And then it stores another byte. So actually we are storing to a7. Interesting. If only I could just plunk it in. So change the loop. Okay. Unfortunately, it's not possible in Hydra. I think at least. So we are storing. So right now EDI is 548. Copy value plus 2 a6. It will be 7EE. No. Bye. Why my math doesn't work? 2a6. For the E 548 plus 2. For the E5 48 plus 2 a6. For the EF E0. Why 0? Because I'm going to the wrong direction. I was talking too much about the reverse for loop that I forgot, but still no. 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 We account from other way, but we are adding +1. So no. Address must go up. But okay, it doesn't matter. Follow in dump. We got this address. And if I will change this byte, we should see it gets back to 0. Okay. Then we again moving next address. Doing the same thing couple more times. Why are you undefined for? Retype. Let you make a pointer. pointer bombs. Why you separated this? This is not a pointer, it's just an address. Double word. Ah, no, wait a minute. I don't know what will be saved in this memory yet. So let it be undefined for now. Okay, so let's jump through this because we know what we are doing. And again, there is another store for word. It's 2 bytes. Then we are moving another address, repstop. Now we are pushing 155. 0 xdbg stores B here. Now, okay, again, there is a strange order. It's first pushing param for this call, but then finishes this this byte to the end of this address. This loop. Okay, store. Then we are pushing xdbg, which was zeroed out. Then we are pushing this address itself. Okay. And we are going in this function. Oh, what are we doing? So this function called a lot of times. So first is address, then 0, then size apparently. For now it will be 0 and size. Let me check quickly where it's called. 0, 26, 0, 155, 0, 0, oh, 20. So it's not always 0. Okay, so at least once. And again. Ah, no, there's a 0. Okay, let's go in and try to understand what the hell is happening in this function. My video is stuck or not? No. So we got address 0155. It's not a 0. Param 2. We got UR 4. Size shifted 2 times to the right until UR is not equal 0. UR, okay, classic for loop. Address concat param concat param. What is concat to 2 a concat 1 1? I see store. Okay, there it is. We got move edx esp plus c. So we are moving into edx. Then we're pushing edi and nullifying result. We are moving into al the same esp plus c. edx 155. Oh, but wait a minute, dc is the because of the push, it's a different value. It's a second param. So we pushed param 2 into lower half of EIX. It's 8 byte. It's this 2. (16-bit) 2 bytes for 8 byte. 2 byte 16-bit. Then we are moving into destination esp plus 8, which is this address which we got fun. Because I was clicking too much, I lost the function. Shish. This, yep. So this is the address in the destination, and we will concat there. We are moving AL into CL. It's a counter. Then we are moving CL into CH. AL into CL. Then we are moving E6 to EIX. Then we're shifting to the left 10 times. But because it's a 0, it doesn't make sense for now. Now we're moving EX into AX, moving EDX to ECX. Okay. we saved size and we are moving it to the right 2 times. So we are basically dividing by 4. Bit shift. 1, 2. But it's R C H. We basically will move this out and this out. We will get 1 0 1 0 1 0 1 0 0 0 0. Because I always forget which one. But anyway, we got there 0. It will not become 1 any. Oh, SHR. SHR. Shifts in the first operand to the left or right by the number of bits. Bits shifted beyond the destination are shifted into the carry flag, then discarded. At the end of the shift operation, the carry flag contains the last bit shifted out. The shift arithmetic left and shift logical left. So SH, it's a logical. Right to still 55. Yep. Interesting. And then we are 55 times saving 0 right now to the address, which is this. And let me check, this is still 0. Okay. And voila, we got 0. Then we are moving EDX into ECX again. And we are ending it by 3. Interesting. Why? The field bitwise end by 3. So we will get only 3. 1, okay. Because 155, yeah, it got 0 here. By 3, it's okay. This one, it's 1, okay. That makes sense. Then it will mean that we will use it only once. I just don't understand why there's a concat if there's actually no concatenation happens. Just storing param2 on the address. Then we again doing this for loop one time, because ECX is 1 on this address actually. Address. So this is basically the value we are saving value. and we are getting out. Store value at address. Okay. Oh, what? Okay. We are store value. This is basically a value. Okay, and C move to 20. Then we are moving D here. Oh, we wrote here several times in different functions. Different things. Only one time there is a actual value, other times it's random stuff. KD, then here we are wow. How many times we write so many times. And we're writing 20, 40, register 40, 20, 40, 40, 40, 40. So most of the time 40, but sometimes there is something. We can't understand what is this. 40, 42. Wait a second, let me check byte pointer. But I can think so. IL. So I can make it it's okay. There is no other option. It's a byte because there is immediately 41 underneath. This one 42 is double word. But it got the next one immediately. 42, 43. And if I will set it as double word, it will overwrite stuff. Wait a second. Byte. Why I decided it? I messed up. This is double word. This is the byte. I looked at the wrong. Highlight is messing with me. Just I highlighted this and I see highlighted this, but it's actually this, it's a secondary highlight. Hey, how are you? Hello, viewer on Kick. I don't see your name, unfortunately. Mazhar. I'm doing fine. How are you? We are modding Vim Hospital here. I'm trying to understand the logic of the game. So next we are moving this here, and we are moving just an address. I'm a professional graphic designer. Do you need? No, thank you. I have professional designer at home. Okay. So let me open this address 56. So we will save this address. Voila. 0048 CBE0. Let's check the write. It writes different addresses. Two of them, to be precise. This or this. So I again lost where is my function. Why is this is not renamed? Ah, it's the wrong function. What is my function? This one. So this is basically a pointer. What is this? It will be here, okay. Now this also saves address in here. Basically, I don't need this bytecodes. We are saving. This all is the same. So we got a lot of stuff here. Type. Can I use this? No, not byte. Data. Pointer. Pointer. You can use it like this. Pointer. Okay. Why are you overlapping? No. Pointer. pointer, 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 pointer. This points to this. Where is 544? This one. Yeah, it. Follow in dump. So it contains the address of this string. No. Let me check again. Constant contains 00 for a deno 060. And on this address we got another address, for fun's sake, and then we got this queue data. It's a file. Can I make it pointer to pointer? Choose data. Or it's a string pointer. Can I find something like that? Terminated C string, but pointer to this string. Char pointer. Kinda. No, don't do it like that. Clean pointer. Interesting. If I will make it terminated C, but pointer. No. Okay, let it be just a pointer. Next. Let me check every address here. So this to string and this to string 448. Double word? No. Interesting. Can I? No. String. Char. Okay. So this is AL, it's a byte. Data byte. It's again AL, so it's again a byte. This is a word. So data word, which got too much hassle. This is a byte. No. Data byte. This byte pointer this is the word. This is the byte. Byte. This is the double word. Byte. Again, byte. More bytes. This all bytes. E, C, D, E, C, D. Okay, they all bytes. This one is also byte. Ow. It's double word. This is byte. This is double word. This is byte. This is double. Now, what we got here? Move that to pointer. Okay, we are at here. We are saving AL20 to 49. So this also was register safe, but it's 20. This is basically here. We got 3, then we got BX, AL, then we are ending AF, by FE, so itself it's 0, will be 0, by X, 0, 0, 0, 0, 0. Wrong mouse. 0, 0, 0, 0, 0. Then this. We will save just this address. Okay. And we're saving 1. And we are comparing this B4 with 0. we didn't use it here. So by default it's 2. And we never actually changed it. Okay. So basically it should never be anything else but 2. Because there is, at least for now, no code which writes to this. It compares. This also compares. Ah, no, but it uses, it reads. Yeah, it just saves it here. Let's rename it to. And we are got do while until it's 0. Move this again. Ah, we are getting address. Ah, it's not the. Then we're grabbing ECX2. Okay. While it's not equal 0, but it will be infinite loop. Or we will change the local variable. We are not changing global. We saved it in the local, and we will manipulate it here. We are adding 8 to EIX, which is address. So we are basically this going like this to here, then here, and here. So we will be moving like 8 bytes until we will stop, I think, on this 0. ECX into 20. Double word. Increment. Increment by I. It's another I. It's this I. Can I split like J? So it should be no. So we will be incrementing by 2 bytes this address. Add we compare EAX with a 0 and jump back. So now it's BC. This we will move 1, add 8, it's 2 bytes, plus 1. Let's see, O is 3 now. We compare this with 1 or with 0. New, we jumping out. Now there's C4. This we will get 10. We are moving to this 20. We will add 10 here. So we get D. This is interesting. Ah, it's a D, it's not a 0. Now we're jumping, we are grabbing 0. Where is it? Ah, but we are grabbing the whole number. Double word, so it's not a 0. Again, 2 bytes. And we are adding all this 0 to D. We are again jumping. So we will have to jump this, 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 this. Oh, we will be jumping up to until here. And we will basically accumulate everything from here. Okay. Four. So many fours. Ah, yeah, 4, 4, 4, 4, 4. 5 times. Okay. $178, $155, 11, 4. Oh, I missed. So we got 0669DA. What does it mean? I don't know. And we saved here 1, saved here. Get hospital, what? Hospital, nothing. Okay, come on. No. This, so wait a minute. This is byte. This also byte. And let me check. It's written only once. So it will be 1. This is written only once. It will be 40. This is a word. It's written several times. Dr. Pop-up index, interesting. Yeah. 90. Okay, it's dot must be double word. No. Oh, it's byte. Byte, because this is oh no, it's double branch. Also byte. Oh, I missed the call. Fun. This is not a byte. It's a word apparently. Hey, what we got here? Return nothing. We're setting a lot of stuff again. Second function, store value, size 0. Let's go in, move byte, pointer byte, word. This is a word. Okay, next. 19. It's written only once here. So it's basically 2. It's basically 0. It's written only 1 again. 19. This word 2 times. This that is a word many times. Oh no, it's not a word, it's byte. Byte. This is byte, which basically 1. Then we are storing these functions. No. Storing value. So there is an address. 1e is the value and 0 is size. But let me check. Size. This. Push. Remove. L is 1e. And EDI is the destination address. This one actually. Follow in dump. So we will move IL in CL 1E here. Then we are moving CL in CH. Oh, and it will be moved to the left. Yes. We duplicate. That's why it's concatenate. Yeah. No, it makes sense. Then we are moving ECX into EX. We are moving to the left 10 times. Okay, we moved it to the left. And we are moving CX to AX. Oh. So we are basically making it 4 times. Then there we got E6 to 2. It will be 0. And we are rep. But there is 0, so it will not be stored. And again we are getting 0. And it again will not be stored. So that's actually useless function. Okay. Then we are moving this and again doing the same stuff, but with this address. Oh, I skipped this function, but anyway, we got zeros. We will not store anything like that, because this is amount of times you need to copy paste this, and this one will be doing the same thing. Let's go in. This is the address. Now we get something in here, but it will be untouched. Yep, it doesn't change anything on this address. Then again, we are here. This is byte. So 75 is a byte. 2F is a byte. Byte. 2D is a byte. 31 is a byte. Byte. Let me check. Written several times. It's several times. Several. Okay. Oh, this is one. So basically 7F. Where is 28? To E is a byte. Byte. Where is 2C? Ah, there. It's 28. Ah, there is 2C. It's the other byte. Oh. No. So this is I6 0x7F. This one also. This no. So we are setting this stuff and just getting out of here. And we are here. This function does something strange. Now I need IVAR7 move BX to BP. It's this. What? We're using it here. Okay, start with arcs. We still got empty stuff here. Next, we are calling this function. Oh, we got to the reading files. Okay. No. Push. 6C, it's a hospital config. Hospital config. What is this? So hospital config. It's the install path, install type, and language, and some some character. Oh shit, I forgot I made it with you. Can I reset? Just I changed a color scheme here. Now I want to change it back. Can I just reset it somehow? Default. I want the default. Maybe xhd reset color. The config file, no. Just delete the ini file, not the lang file to reset your options. Let's try. Ini. Maybe I can just clear some colors here. History, toolbar is down, toolbar. Options. Expert font, okay. Modified attributes. Maybe if I will remove this. Oh, maybe I can change theme. Theme default. No, doesn't change much. Changes only panels. Let's try it. Offset, data, color. Maybe this will help. Yay! I resetted it. What is this last one? 1.8. what is the sequence? Okay, let's jump inside this function, read file and uncompress. So we are searching for RNC signature, which signifies that this file is compressed. So from what I read, game understands compressed file and uncompressed equally. So you can where is it? Like there is RNC. So it means that this is compressed file. You can uncompress this file, name it like that, and place it in the same folder, and it will still read it fine. So it's sometimes useful when you test stuff. So you can uncompress file, move something in them, and don't bother to compress it back. So right now, if I will look at this config file, so this is our thing, it's not compressed. So we should read it fine. Sub, okay. Then we are moving in the signature RNC and is actually 1. Let me check again. Yep, there is a 1. So it's not a 0 terminated, but 1. Can I change this? No. It's meant to be that, like that. No, we saved it. No, it's 0 terminated. 52 RNC 1 0. Why I don't see 5th element? There it is. Because we lost this part for some reason. We are pushing ESI, which is this thing. We're just saving it. Okay, we are storing this on the stack for later use. Then we are moving these things, which contains hospital config. Yes, spam. So we get this somewhere, this one. Because yes, pair 8, let me check, it should work properly. space pointing to 19FE88 plus 1C. It will point here where we got hospital config addresses. So we got this address, and ESI will get, voila, this address. We will push 2. So it's a path. To again ESI. Here we moved and there we pushed, yes. And we got 2 arguments for this function. Now, which is file name and creation disposition. We will get back just handler. Desert access. Let me check. Your method desire access file. Disposition. So this is all for create file A. This desired access first param. Second. Generic read, generic write. For more information, access write. Generic. So generic read. This generic. Or it can be mask. Oh, security access, right? File, but still generic file. No. File access and access mask. File. Access. So apparently it's a combination, some of them, that's why it can't understand them. Too bad. So, okay. We can omit this. After call, yeah, I noted here, I think, for the share read and share write and desired access, I didn't bother. We got handler, which is, size, which is C. Oh shit. C, which is 12. Interesting. Because config is actually 55 bytes. Why? Create file and get size. All right. Where am I? Am I even here? Wait a minute. No. We are here. It's handler. Okay. So add, it's a handler. Okay. So destination is a handler. Compare with -1. Why I can't change it to -1? Decimal. Red. So compare jump is taken. Now we are load is plus 10 0. So we grabbed address itself. Okay. Then we're pushing 8. File header. And handler. So there will be stored the file header. Buffer number of bytes to read. We need to read 8 bytes. So like that. And it will be compared with a signature. Compare result. So we got 8. It's how many we read. Number of bytes read. If if it's not -1, we will jump. Here is file closed. Interesting, we are ignoring the result. So basically this function closes file close file. Handler. It may be used not only for files, I think. So we read it and we are closing it. Okay. Then we are grabbing this here address and this address. It's again buffers to compare. Here we got this and here we got this. Push, 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 we are comparing. String compare returns. Was it compared successfully? Not exactly. Yeah, string compare. So string 1, string 2, size. Okay. And it returns integer. Integer value relationship between the strings. The string character does not match, has a lower value. Content of both are equal. Okay, so I need to split u. That's why I was compare result here. And why u renamed? Okay, compare result equal 0, return handle. Whoop. What the hell? Let's see. Call to compare, it returns -1. So we compared I lost this. Okay, so we compared basically this signature and this bytes. We got mismatch because it's not compressed. Test EIX is -1. We will go out of here under the file size. we are getting this for some reason. And we get 37. What the file was? Hospital.conf. File size, and then -1. Strange. 37. It's 55. Wait a minute. 37. Yeah, we got 55 bytes. I forgot to convert it. So yeah, config file is 55 bytes. So 37. Yep. Yeah, length 37. No. We are going out of here to here. We are storing the result, which is size 37. Okay, adding, comparing AX with a -1. It's a little annoying that this can have a size and the result of a function, which can be -1 when it's not found. What is the size? Why you handle? The type, you must be int. Okay, let's go. We still don't get anything here. Jump not equal. Yes, we're jumping over this if. We are moving here, basically the same result. Size. We are create and allocate heap. I think it's a name clash. I pressed F9. Use Hanover. Let's restart it. I need again open all my addresses, breakpoints. Where is my main function? So here we are here. Let's quickly jump through this. So this we know. Keep created, okay, and we are inside this function. Oh no, we already in 40. Yep, this function we did, and we need to go inside this. Call 80 this file size. Why function int where is a simple int? bcd int. Okay. Now call 80 again 37. Then we jumped to the allocate. We allocated. We got memory, which I don't recognize its memory address. Okay. Jump. We created, so we are good. Then uncompress. Let's go in. So we got this address where file name is stored apparently. Yeah, it's just a name. Why I'm clicking everywhere? String. So install type, install path. And hospital config. Fun uncompressed. Not really fun. 7. Okay. So we got path and the param2. What is the param2? help mem. So it's a memory address. It's where we will read it apparently. Get file header. Yeah, buffer. It's a buffer for reading, which we pass from up there. Okay. We got host. So we will read here. ESI hosp config. Push, and we read file and uncompress again. And we'll again grab the same value of 37. Yep. Hospital integer. It's basically the size which we will need to read. Jump, call, create file with we will get handler. We check handler -1, and we are getting in. We are moving this address into EDI. Which is this, which was passed here. Push. And we will call 37 mount, buffer, and handler. We will again get 37. If it's not -1, we go in. Push handler, close handler, extra out. Oof, I don't like this. And yes, push. EDI. So 2 times. We push this memory, yes, and this is some stack address apparently, and hospital entry point. What? I think there is some problem. It's not supposed to be here, I think. We are going in. So maybe there will be only 2 params, not 4. Yeah. We are not using these 2 params at all. No, we are using it here. The second one at least. Interesting. Let me check. If I will just remove and change it. Let me Ah, wait a minute. E6, EDX. Huh. Maybe it's not a fast call. And this is STD. Still 4 params. Unaffected, unaffected. This call. No. Okay. Let it be like that for now. Oh no. Decal, but with 2 params. In EDX. Extra out. Okay, let's check then. So we got 2 here and 2 here. Let's go in. Push, push. Just we are pushing E6 and EDX on stack. Usually it means that we are saving it to not corrupt, so we're not supposed to use them. CLD, what the hell is this? I don't have a manuals on me, yeah? Oh no, wait. It works. I copy pasted my old installation of Ghidra, that's why I got the docs here. Hello, Girly Pro. How are you? I'm fine, thanks. And how are you? Only problem with documentation, it doesn't find the correct spot. CLD, where is it? Good, still ill though. Oh. So what this hospital game? Let me show you. So, in hospital. So basically it's a hospital simulator, but it got a really funny thing. They got really interesting diseases and stuff. So where's the game? Actually, it's on go. Loading. Let me find my playthrough. If you're interested, you can. If you're interested, you can just watch my playthrough. So basically, yep, you. Oh. What happened with oh, it doesn't exist here. There must be, yeah, but this one. So, disasters. So yeah, the fun things about this game, you're not just building and curing people. There may be, like, for example, earthquakes, which can destroy your stuff. Vomit waves, earthquakes, a boiler, not so interesting. It's when your boiler is breaking. It can become too hot or too cold. Rats is kinda funny. You can shoot your rats when they run on you throughout your hospital, and there's a separate rat level if you are not good with them, I think. But the freaking animation is something in this game. The pictures are too small. Yeah, select tongue. Fracture bone, priorities. So they don't have a picture for it. So if you will try and check your emojis, you can find like flag tongue, floaty head, King syndrome. This is a hiatus one, and it's an animated one. That's Grim Reaper from the game, which grabs people when they die. Where is if you don't want to buy like original game, you can play Corsic TH. It's an open source clone of this game. It lacks some features from the game, but it's pretty playable right now. They got the complete campaign working. There is also aliens at the all last stages. Strange. I thought this wiki got every disease with yeah, jellyitis. People walking and like like a jelly. That's like it's an old game, so graphic is pixelated basically, but the style of the game is just awesome. Can I play any videos without lagging? There is basically a lot of dark humor in the game. Will it handle it? So basically you're building stuff, you hiring stuff, you curing people. Will there be anyone? Oh, I can do the simple thing. Now we are a little bit lagging. Can I run second copy? Window. So let it be like that. There must be some late stages here. So basically there is a hospital. There is a lot of people. You need to clean it up also. It's after my testings. It's a little bit dirty. Yeah, there is epidemic. Oh, and it's lagging as something. So no, it will crush me. My laptop can't handle this, sorry. So better watch my playthrough on the YouTube. Where is the CLD? Oh, there's so many. Okay, there's CL. Clean direction flag. Clear the DF flags and the E flags register. Set to 0 string operations. Increment in registers. In all modes. So it's in which side it increments. Okay. Direction flag is 0. We are pushing DS. The segments. ES. Oof. Move EBP. So this is our memory. Load SW. Oh, what is this? There load SW load string SW where loads a byte word double word into case, so double word we will use EAX from the source. What is the source? From this GSI. Oh, we read here our config. Where is it? We're comparing AX. Huh, interesting. With this. And it's a memory. I don't know why there is two of them, but okay. That's a pointer. Undefined. Undefined. And there is a pointer. Why there is undefined? Okay. Oh, wait a minute. For E52. Char. Error above. Where's something? $52 for E, so it's this which is actually looking for, and 0143, it's again this, so it tries to find this RNC. Okay. So it loads the string and tries to find the compression node. Where is it? Where? Check for RNC. C and something. Okay. So this big if is just checking memory for this. If it compressed, if it's equal, it will go here and uncompress it. So we should go here and set it to 0. So it maybe is compressed. So we are loading here for E49. It's this for E49. Then we're comparing it and it's failing immediately. We are jumping out. Move 0, jump. Jump. STC. I need index. STC. Set carry flag. Okay. Set carry flag to 1 apparently. How we concat this? With param2. CX, it must be EDX. EDX is 0. And we are returning here. Call. So we got here return with 0. So we need to check some compressed files to understand this. Test var less than 0. Print string error decompressing. So if it's -1, it will be error. Everything else is okay. Jump is taking var 0. Number of bytes to read 0. Heap created. And again, we got 37. Oh, we got here. Oof. Jump not equal. Let me bookmark this function. Can I do it? Main. Okay. Let me this. I hope I will remember about this comment next time. Continue here. So we got somewhere here, so I'm a little bit lost already. So we are comparing 54, 41, 54, 41. So we are getting one by one. We are searching for something. Do while it not equal new line. But yeah, there is a new line. I think it's install possible install. Yeah, there is must be a new line. There is 010. So it parses line by line. Okay. Can I place prayer parses line by line? Kinda like that. Okay. And jump 5F 51 54 48 D 2E 5C A. Jump, and we will jump out, load this, which is basically the string 49 for E 53 44 of this part. So get address with this. We will concatenate, remove this, move, and we got, yep, install buff. Ta-ta-ta. Ooh. Jump. 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 We are searching for 3D. Oh, 3D is the equal sign, so yeah, we're parsing split by equal. Ah, there it is, yeah. Ah, no, why? There is a and then by 3D, okay. So it's searching for 2. Jump. Jump. Okay, so it parses the arguments somehow. Okay, so I have to wrap this up for today. So I will see you all on the next week with more Team Hospital, but tomorrow there will be another stream with StarCraft. We will still be playing the campaign and raising money for charity, so don't miss it. Have a good rest of your day, have a good rest of your evening, and bye bye.